For our project, we looked at the question, do ellipticals or spirals have a higher stellar mass?
Stellar masses are the measurements of mass for the galaxy stars that they compare to our Sun's mass. The statistics we got conclude that all catalog galaxies have a stellar mass ranging from 8.875 times 10 to the 10th to 12.375 times 10 to the 10th. These statistics show that when it comes to all elliptical galaxies, red or blue, the mean stellar mass is around 10.735 times 10 to the 10th. The statistics show that spiral galaxies range from 9.507 times 10 to the 10th to 11.414 times 10 to the 10th. Take note that spiral stats do not look too different from the ones of ellipticals.
Through the research we have conducted and the data we have analyzed, we see a correlation between a galaxy's stellar mass and the type of galaxy it is. We can expand our proof that ellipticals have a higher stellar mass in general when we see that elliptical galaxies hold a higher maximum stellar mass than spiral galaxies. Ellipticals have a maximum stellar mass of 12.243 times 10 to the 10th, and spirals have a maximum stellar mass of 11.414 times 10 to the 10th. This image shows a Hubble tuning fork, which is used to identify and classify if a galaxy is elliptical or spiral. It is seen through this image that the color of a galaxy changes with the type of galaxy. A spiral is blue, and an elliptical is red. The change in color is due to the type of stars within the galaxy. Blue stars are large and massive, but they do not have as much of an effect on the stellar mass as we had originally expected. This graph depicts the difference in stellar mass between elliptical and spiral galaxies. The dotted lines are for early type spirals, the dashed lines are for late type spirals, and the solid lines are for ellipticals. This graph agrees with what we have found in our data, which tells us that ellipticals do have a higher stellar mass in comparison to spirals.
Our initial hypothesis was that spirals would have a higher stellar mass when compared to elliptical galaxies because of their reduction of high-mass stars.
When starting this project, we assumed that spirals would have a higher stellar mass range due to them actively producing stars. Our conclusion proved this to be wrong.
We thought creatively after learning that log numbers were 10 to the 10. This changed our data.
To analyze the data, we used Galaxy Zoo and Zoo tools and were able to summarize the galaxy's stellar masses into a range of 8.875 times 10 to the 10th power to 12.375 times 10 to the 10th power. The spirals had a significantly lower stellar mass range when compared to ellipticals.
In conclusion, after analyzing the statistics to find the graph, we can answer the questions: do ellipticals or spirals have a higher stellar mass? Elliptical galaxies have a significantly higher range of stellar mass than spiral. This is assumed due to the galaxy's compressed nature as opposed to spirals' wide open arms.
To add and follow up on our research, we could ask, how does a galaxy's color, red or blue, compare to its stellar mass?
During this project, we learned that science is not a direct path from question to answer. You need to be willing to take in the advice and experience of others and be open to learning during the whole process.